Welcome everyone. Today we will discuss probabilistic or stochastic modeling in inventory management. We know that in inventory management, broadly speaking, there are two different types of models. One is deterministic model where the demand or the exact demand is known, and another is probabilistic or stochastic model where the exact demand is unknown. Now, in case of probabilistic model, we will see that how to determine the safety stock, because the safety stock, we all know the concept of the safety stock, that the concept of safety stock, it will depend upon the stochastic model or the probabilistic model. Why? Because in case of the during the lead time, the amount that will be served, that is obviously the average demand during the lead time, that means average demand per day into the lead time, that means the duration of the lead time, that is the total service you will actually make, okay, which is also known as the reorder point. So that is fixed. That means the lead time demand, that is known. It is based on the deterministic model. You can find out that what will be your lead time demand, but you cannot determine the safety stock based on the deterministic model. The safety stock, the concept of safety stock is that the safety stock must serve the excess demand during the lead time period. Okay. And we have also seen that practically the demands are not like straight line. It looks like somewhat like this. Okay. So practically we need to have safety stock because the demand actually fluctuates. Okay. And maybe during the lead time, the kind of demand that we have assumed, the entire demand or the total demand during the lead time, it may not be the same. It may be higher than that. So to meet the excess demand, the safety stock, it is actually required. So how to calculate the safety stock? It will depend upon the variation in demand during the lead time. So that's why here actually the concept of statistics comes, and that's why it is known as the stochastic model or the probabilistic model. So before starting the point of how to calculate the safety stock, we need to know some prerequisites or some basic things, that is the service level. This is a very important thing. What is service level? As per the definition, service level is a measure of the degree of stock out protection provided by a given amount of safety inventory. So basically, service level, it is a measure of the degree of stock out protection. That means it is the measure of that, it is the measure of service ability when you are not facing any kind of stock out problem. It is just opposite to risk. Suppose your service level is 95%, that means your risk is 100 minus 95 is equal to 5%. That means there is a 5% chance of risk. Risk means that there will be of stock out even if you have the safety stock or the buffer stock, and there is a 95% probability that you will be able to meet the demand of the customers during the lead time. There is 95% probability if your service level is 95%. So service level, it is given by probability of the lead time demand mu is less than or equal to the reorder point, or it is also determined, it is also given by beta. So why it is like this? So reorder point means the actually this is the service level. This is uh, it is during the lead time period. This is the service level for the lead time period. Okay, so that the lead time demand, it will be less than or equal to the reorder point. Why it is like that? Because if you look at your reorder point, then this is your reorder point. This is your reorder point. Okay, and this is the lead time demand. If it is less than or equal to the reorder point, then only you will be able to provide, or you will be able to meet the entire customer's demand. Okay, when you are not having the safety stock, okay, safety stock or buffer stock during that time. And so this is the concept of the service level. So we can use also the same concept. Okay, how I am showing that? Actually here the reorder point means this plus this. That means it includes the safety stock, and this during lead time demand. Okay, that means when you are placing the order, from that date to when you are receiving the order, up to that date, that entire demand must be less than or equal to this amount plus the safety stock. Okay, it should be less than this amount plus this. So this is the service level. Okay, and If we consider the opposite thing, then obviously that denotes the risk factor. Suppose if you want to find out the risk, then it will be like probability that lead time demand will be greater than or greater than the greater than this reorder point, which also includes the safety stock. Okay, that means you won't be able to meet the entire demand of the customers during the lead time. So what is the probability of that? Okay, so that is actually, that will be the risk. So that's why the service level, it is represented as this, and risk factor, that is also given in that way. Now, one important thing is we need to notice that in practice and theoretically as well, the service level we always want, it is greater than or equal to the 50%. That means the service level in practice or in reality, and also theoretically speaking, in reality, it it cannot be, service level cannot be less than 50%. Similarly, the risk also has to be less than 50%, but it cannot be greater than 50% risk. Why? Because statistically speaking, if your service level is less than 50%, then you cannot meet the entire demand of the customers. Similarly, if your risk is greater than 50%, then also you are not able to meet the entire demand of the customers during the lead time. Okay, so we will later on, we will see it with the help of an example. So now our objective is to how to calculate the safety stock. Okay, so let's take a look at that, how to calculate the safety stock. Now we know that the reorder point, it is given by the lead time demand, which is given by d bar into L, average daily demand into lead time. This is nothing new, plus Z into sigma D into root L. This is the formula for the safety stock. Now the question is that how we will derive this formula. Okay, so if we want to derive this formula, first we need to understand that what are the primary components in this formula. The primary components in this formula is, one is Z, and then this sigma D into root L. This entire thing, it is actually the standard deviation during the entire lead time. The entire lead time standard deviation is given by sigma D into root L. So basically this is the standard deviation, sigma D into root L, and this is your Z. Okay, so Z into the standard deviation, this is actually you are doing when you are calculating or when you are determining the safety stock. Now, why we are doing this? You need to look at this step. Suppose when you suppose this is an example, okay, that I very often that I discuss, that there is a series of the students' results that they have scored. This is the marks out of 60. Okay, so these are all the X values given. Now, if you want to standardize this course, what these values, then what you will do? You will use this formula, this data point minus mean divided by standard deviation. So you will calculate the mean first. Mean is 23, and you will subtract the mean from all the individual values in this series, and then you will divide it by the standard deviation sigma 6.6. So if you do that, you will be getting these values. Okay, so which these values basically, these represent Z scores or Z scores. So your Z score, it is given by data point you are doing here. You are using this formula, this data point minus mean divided by sigma. So basically when you are, if you do the cross multiplication here, then you will be getting Z into standard deviation is equal to the difference between the data point and the mean value, the difference between the mean value and some data point. Okay, difference between the mean value and some data point, that is equal to Z into standard deviation. So this is that. So here also you are doing the same thing. This is your mean, which is the mean is actually, it is the D bar into L. This is your mean, and here the R, it is actually the reorder point. Okay, so why it is D bar into L? Why it is D bar into L? You notice this picture. Okay, so in this picture you can understand that the mean is equal to 1000. What is mean? Mean means the average demand that you see during the lead time, that is actually your mean value. So here it is, suppose given it is 1000. Okay, and if you want to ask that what is the service level of your mean value, that will be obviously, that will be 50%. This is quite natural. You can use your common sense for that. What you are getting when we say that on an average this thing we are getting, that means that represents the service level of 50%. Okay, and what is the risk of that? The risk is also, there will be the 50% risk will be also associated with it. Okay, so this is the risks that will be associated with it. Okay. Now when you are saying that your reorder point is 1200, that means the entire thing, it is actually that means it is actually this if represents 1200, that means this is representing 200. It is actually basically your safety stock. Okay, this is basically your safety stock, and this is your reorder point. Now if somebody asks you that what is the level, service level here, that means the entire area under the car, that will be the service level, because you have increased the number of items in your hand by the safety stock. Okay, so the entire, so if your reorder point is 1200, obviously the service level will cover some greater area. So here, when you are considering Z into standard deviation, that is, it is equal to actually this, that reorder point minus mu. It is actually reorder point. Reorder point means that includes that mu plus safety stock. So reorder point minus mu. So it's just very much similar to this. Okay, similar to this, that X means the exact data in the series that you are considering, and there you are considering the reorder point. Okay, which is which will depend upon you, what kind of percentage of service level or the risk level you desire, minus mu, which is the mean, and then you are dividing it, sorry, this is equal to Z into sigma, or the standard deviation. So now it is clear to you that why it is Z into sigma. Why? Because the reorder point is given by the demand during lead time plus the safety stock. So demand during lead time is given by d bar into L, average daily demand into lead time, plus safety stock can be also written as, safety stock means your reorder point minus mu. Mu means the demand during the lead, average demand during the lead time. So ROP minus mu can be written as here the Z into sigma d into root L, or the Z into standard deviation during the entire lead time period. Okay, so why it is written like this? Because it's just simple, it follows the Z formula from X, it depends upon this. We can write it like this. So now the question is, why the standard deviation is written in sigma d into root L like this? The answer is actually sigma d. It is the standard deviation of the daily demand. Okay, it is the standard deviation of the daily demand. So if the standard deviation of the daily demand is sigma d, then the variance of the daily demand, it will be sigma d square. Okay, suppose uh, sigma d is equal to, given, suppose sigma d is equal to 5 items. Okay, so what will be the sigma d square? It will be 25. Okay, 25 is the variance. That means from standard deviation, when you are moving towards variance, that means you are going back to its the original unit of the item, original unit. Okay, so the variation for daily variation is, you can understand that the daily variation is 25 items. Okay, now if the daily variation is 25, then what will be the total variation during the lead time? Suppose if the lead time is, for example, 9 days, so the entire variation during the lead time, it could be 25 into 9, so 225. So in this case also, the for the entire duration of the lead time, the variance could be the daily variances, which is sigma d square into L. Okay, why it is written like that? Because the reason is very simple. Say, if for one day, if the variance is 25 items, that means, what does it mean? Suppose on an average, your sale is, suppose 25, suppose 100 items you sell. If your variance is 25, that means maximum up to, it can get up to 125 items also you can sell. So if your 9 days, it is the due, it is the your the lead time, then for each and every day, that means first day of the lead time, second day of the lead time, third day of the lead time, fourth day of the lead time, for all the days, your items can go above the 100, and it can touch up to 125 items. So as a result of that, if your lead time is for 9 days, so 25 into 9 is equal to 225. So all together, 225 items you need to have in your hand, because this is the entire variance. So this is the given by the sigma d square into L. This is the entire variance. And what will be the standard deviation of it? The standard deviation, if you do it, then it will again become sigma d into root L. Okay, so this will be your variation. Sorry, this will be your standard deviation. So this standard deviation, sigma d into root L, you need to put here z into your standard deviation will be standard deviation during the entire lead time. This is the sigma d into root L, and that's why this formula, it looks like this. Okay, so this is the way that you calculate the safety stock and also the reorder point. This obviously, the safety stock, that will not, you cannot say, what I mean to say, it's not like that the safety stock will be 225 items. If you can save 225 items, then you will not meet any stock out. I'm not saying that, but I mean, for the purpose of the safety stock, you are basically, I mean, in terms of the variance for the entire duration, that will be the case of variance. That means how to calculate it. Okay, so if it is 5 sigma d, then 5 square is equal to 25 into 9, it will be 225. So that is the process of how we calculate the variance. Okay, but that is not how you determine the safety stock. It's not like that. That's not the way how the safety stock is determined. Okay. Now the thing is that there is the problem is given that reorder point with the variable demand that is given, and all the data these are given. You will just plug in the data and you will be calculating your the values of just so all the the data's all the data you need to calculate the you will plug in the values of the Z, the service level. If it is given at 95%, then at 95%, what will be the value of Z that you will have to put here, and you will be calculating the safety stock and the reorder points. Okay. Now, interesting to note here that at 95% service level, the Z value, it is 1.65. It is why it is 1.65, because you are basically here considering one tail test. It is not a two tail test. In case of a two tail test, the value is like 1.96 or something like that. Okay. But in this case, the value is not uh, 1.96. In this case, the value is 1.65. If I enlarge it, you can see that this curve, which covers greater than 50% area, for that curve, and this table is used. Okay. And in this case, the Z values that you will get, all these positive Z values you will be getting. And you can see that for 1.65, the value is 0.95. Okay. But there is also this sort of curve is there, which considers the Z value, all the Z value here, those are negative Z values are there. And when you will have a service level of less than the 50%, at that point of time you will have to use this kind of curve, sorry, this table you will be using. But actually you will get some negative values of the safety stock during that time. Okay. So if you do that here, suppose if your the safety stock, it is, suppose it is said that your what will be the if you desire a service level of 13% for say, okay, it is not actually desired in practice. 13% service, it nobody desires, and also it cannot be the service level, it cannot be less than 50%, because in that case there will be greater it is not less than 50, it is less than 50%, it's not greater than 50%. Okay. So if you have desire a service level of 13%, then what will happen? You just see that 13, nowhere you will be getting the value of 13 here. You will be getting the value of 13 here. Okay, 0.1292, that means the 13 value. And when your Z value will be minus 1.13. Okay, so you will minus 1.13, that will be your Z value. Okay, so you will get here minus 1.13 value. Okay, so your safety stock in that case, it will be actually negative. Okay, so your safety stock will be negative in that case. Okay, so and which is practically, it is I mean, it is actually, it is infeasible. The safety stock is negative, it's infeasible actually. So what, suppose if we have, if suppose if you want a service level of 50%, then what will happen? If you see it 50% case, for 50% you can see that automatically we know that Z is the value for 50%, 0.5. This value for Z, when you will get Z value is 0, and it is common sense that when the Z value will be 0, then you will have a service level of 50%, because the area under the curve, this will be 50%. Okay, so if you put here, so Z value, if you put here 0, the safety stock will be 0. So what does it mean? It means if you desire a service level of 50% only, then there is no need of safety stock. Okay, there is no need of safety stock, and in that case also you will have 50% chance of 50% risk factor will be also there. Okay, but if you usually you don't do that. Okay, so you want a greater service level. Okay, and accordingly you basically calculate the safety stock. Okay, so this is the explanation of the basic stochastic model in inventory management. So thank you all.